Good morning, guys. Today we are continuing in conic sections and we are going to look at ellipses today. So first off, start with your bell ringer. Go ahead and pick two volunteers, have two people come up to the board to put these problems on the board, and when you are done, we will go over them together. Okay. It says, write the equation of a parabola with a vertex at the origin and a focus of 0, -4. So if I look at my little sketch here, it's saying my focus is down here. So I know my parabola has to open down, so it's going to be an x squared, and it should be a negative value. This is my a value, so I'm going to have 4 times -4 times x. So I'm going to get x squared equals, I do that every time, y goes there. So that should be -16y. And that's it. That's our final answer. For the second one, it says find the focus and directrix of the parabola given by the equation x equals 1/2 y squared. Then sketch the graph. I want the y squared to be by itself, so I'm going to divide by 1/2 or multiply by 2. And I'm going to get y squared equals 2x. To find the focus and directrix, I'm going to take the value that's in front of x and set it equal to 4 times a. Divide by 4. And a is going to be 1/2. Now, I know it's weird that those matched up. It usually doesn't end up being that way. This is a very special circumstance. But that means that our focus is going to be, if we're doing a y squared, we know that it has to open right because it's a positive number. So it's going to be at 1/2, 0. And our directrix is going to be not a parenthesis. It's going to be at a vertical line, so x equals -1/2. So I'm going to graph these points. I've got the 1/2. Didn't mean to do that, sorry. And then x equals -1/2. Ooh, that's a bad straight line. But you guys don't judge me. So there's that, and then I just need to fill in the graph, which should, or the parabola part, and it should look like this. And that's it. All right, so today we're looking at ellipses, and there are some key terms we need to know. So first is focus. So there was a focus in the parabola. Today we're looking at ellipses. They actually have two of these, and when they're plural, we call them foci. So there's one here, and there's one here. And the foci work together because if I draw a line from this focus to right here, it's going to be equidistant to here. So foci are help us figure out our equation of the ellipse. The other thing we need to know is the major axis is the segment that contains the foci. So the major axis is going to be the longer one. It's always longer. In this case, you can see here it's vertical. It can go either way, but it has to contain the foci. And then the minor axis is the one that's perpendicular to that. It goes the other direction. And again, it can go either vertically or horizontally. The vertex, the vertices are points that are on the major axis at the end of it, and they help us find our shape. So here and here. And then the co-vertices are the endpoints on the minor axis. So between those 4 points, we kind of get our shape of what the ellipse should look like. These are our equations. If it's a longer on the horizontal, then it's going to use this equation, x squared over a squared plus y squared over b squared equals 1. If it's longer on the vertical, it's going to still go x squared and y squared in the numerator, but the a and the b are going to be different. So what you need to take away from this is that a is the greater value. and B is the lesser value. So x and y are going to always go in the same order, but I'm going to look at which number is bigger under the x and the y, and that's going to tell me if it is longer on the horizontal axis or the vertical axis. So my equation for my vertices is just going to be plus or minus a, 0, 0 plus or minus b over here if it's a horizontal. And if it's a vertical, it's going to be very similar. It's just that we're switching the order of a and 0 here and the b and the 0 here from what it was originally. So take a minute, jot this down, draw a little sketch so that you know what you're dealing with, and then go ahead and resume the video when you're ready to move on. Okay, write the equation in standard form of an ellipse that has a vertex at 0, 5, a co-vertex at 2, 0, and a center at the origin. So, if I look back here, I know that my vertices are, if they're at 0 plus or minus a, that means that it's going to be longer on the vertical axis. And so that's what I have here. My vertex is at 0, 5. So if I just kind of even sketch a little graph, 1, 2, 3, 4, 5. It's 5 on both directions. There's one vertex here, but that means there's another vertex at 0, negative 5. There's a co-vertex at 0, 2, and at negative 2, 0. And we can see from our sketch even that it should be longer on the the y-axis than it is the x-axis. And so what we're going to do is we're going to keep our x squared and our y squared. It's always plus, and it's always equal to 1. Now, for the numbers underneath, what I'm going to do is I'm going to say it's longer in the y-axis, so this has to be the bigger number. And I'm going to say, okay, I've got a 5 here, so I'm going to put 5 squared, because it always has to be squared. And then this is my lesser value, and this is going to go here under the x, so I'm going to get 2 squared. So rewriting this, finally, I would get x squared over 4 plus y squared over 25, and it's always equal to 1, and that would be my final answer. So the other way I can look at this is to say, okay, 5 is in the y coordinate, so it needs to go under the y. 2 is in the x coordinate, so it needs to go under the x. If the sketch helps you, you can do that. If you need to think about like this is y, goes under y, whatever works for you. There are multiple ways to think of it. Write the equation in standard form of an ellipse that has a vertex at negative 6, 0. Negative 6 is in the x coordinate, and a co-vertex at 0, 3, and 3 is in the y coordinate. So I've got x squared plus y squared equals 1. Now, negative 6 is in the denominator, is in the x coordinate, and so it's going to go in the denominator under x. And 3 is in the y coordinate, so it's going to go under the y. And we're going to get x squared over 36 plus y squared over 9 equals 1. And that's it. That's all we're doing for these first few. So let's do one more. Vertex at 0, negative 4. So that's in the y coordinate. So I'm going to have y squared over negative 4 squared. X coordinate of positive 3. So I'm going to have 3 squared. And I've got x squared over 9 plus y squared over 16 equals 1. And that's it. So then we need to talk about how do we use the foci. So if we say that C is the distance from the vertex to the foci, we call that C. And we're going to call this the C value right here. These are our foci. How far away is it? And then the B value is going to be the distance to the co-vertex, or whatever our co-vertex is. And then this A value is what we're going to have to find. So, find the foci of the ellipse with the equation 9x squared plus y squared equals 36 and graph the ellipse. All right, so we are going to have to start with this problem by putting it in standard form. So in standard form, remember, it has to equal 1, and this is obviously not 1. So what I'm going to do is I'm going to divide by 36 on all sides. And here, that's going to cancel out and give me the 1 that I need. I'm just going to have y squared over 36, and then 9 over 36, if I simplify both of those, I can divide by 9, and I would get 1 over 4. All right, so there's my standard form, but now I need to find the foci. So what I'm going to do is I'm going to say I know what a squared is. A squared is always the bigger number. So I'm going to have a squared. I have b squared. And I need to find c squared. So I'm going to have c squared equals 36 minus 4. So I get c squared equals, when I do 36 minus 4, I get 32. And if I want to simplify that more, I've got to take the square root. I could write it as a simplified radical. If I take the square root of 32, though, I should get c equals 5 point something. If we want to be specific, the square root of 32 is 5 point, we'll call it 657. So the foci, they're always on the major axis, and since 36 is the bigger number, I know that the major axis is going to be vertical. It's going to be on the y-axis. So it's going to be at 0 plus or minus 5.657. Because I have two. So I have the positive and I have the negative. So then I'm going to graph this. I've got my major axis is on the y-axis, and so I have to take the square root of 36 to find my a value. My a value would be 6. My v value would be 2. So I get 6 and negative 6, 2 and negative 2. And I'm going to go ahead and graph my foci. And that's a good check because the foci, they might be closer to the vertices or they might be closer to the vertex, or the origin, excuse me, but they should be within the confines of the ellipse. It's not the best drawing. It should actually stay within the 2, but that's okay. And again, it's just kind of a good check because if you find your foci and then you graph them and they end up out here, you know that something's wrong. So let's look at another one. Find the foci of the ellipse with the equation x squared plus 9y squared equals 9. So I need it in standard form, so I'm going to divide by 9 on all sides, on everything. And I'm going to get x squared over 9 plus y squared, I'm going to go ahead and put over 1 for right now, equals 1. I can see that because the number under x squared is larger, that's where my major axis is going to be. It's going to be larger on the x-axis. So let's find our foci. We're going to have c squared equals a squared is 9, b squared is 1. So I'm going to have c squared equals 8. And when I take the square root of 8, I should get 2.83. So I'm going to say that my foci are at plus or minus 2.83, comma 0. When I graph those, it should look like this. Now, graphing the rest of it, my a value is the larger one, so this is the a squared. This is b squared, so I have to take the square root of each of those, and I get a equals 3, b equals 1. Graphing those, and it should look like that. There we go. I'm going to have to continue this lesson in one more video, so switch over real quick and we'll continue there.